Memory leak occurs in C++ when memory is allocated dynamically and is not properly released or deallocated before program terminates, and or maybe that memory gone out of the scope, or when we lose any reference of that particular memory, so then we got that memory leak. And yes, after this we can't access that memory, and we will lose that memory gradually if we got memory leak over the time. And yes, so memory leak also occurs in this scenario, like when we forgot to delete, when we use new keyword and forgot to delete that memory. Also we use a pointer and we override that pointer again with new memory or maybe a different pointer. So in that case we just got the memory leak. So we can use delete when we got new, and also we have to if we are going to override any pointer, we have to clear that memory first and then use new value to that pointer. So in that case we can use also a smart pointer. So we have several in smart pointer. One is unique pointer, second is shared pointer, and third is the weak pointer. So unique pointer is a pointer in which we assign a single value, and the ownership are there for that single value. In shared pointer we share the same memory to other variable also, and in weak pointer we just use shared value, but we don't use the count of that reference there. Reference count is not there in weak but in shared also. So main difference between unique pointer in this smart pointer in term of occupation. So unique pointer has occupied only one single resource. If we want to pass this value to another, so we have to move that reference to another unique pointer in shared. But in the shared pointer we can pass this same memory location to other also, other shared pointer, but we can use the counter, shared counter in that case. And in weak we don't maintain any share counter, and we don't have any ownership on that location. In term of release, so unique pointer automatically release when it goes out of the scope, and in a shared pointer when the counter reduces to 1, then it will execute that destructor part, deallocation part. And weak pointer we don't maintain the deallocation part. Okay, so next is the 5 segments of the memory. So we have first is the our text or code segment, where we put our text, which is read only, and we can't write anything there, and we fetch the code from there and execute that code. And next is the initialized segment. So in this segment we have the static and global initialized variables here. And next is uninitialized. We put the uninitialized variables here, static or also which is initialized with 0. And next is our um, uh, heap. So we manage here the all the dynamically allocated memory here, and put the all variables here which is dynamically allocated, like a reference type like object we creating there and put there. Stack, next is the stack, fifth is the stack. So in this pointer we just manage the local variables and function call there, so it will act as a last in and first out. So yeah, that is.